Okay, sorry, I had to take another video because it got too long. So first of all, I would like to apologize. I was checking the charges of these two elements and turns out the correct way to write it is this, not this. So I'm sorry for that. And now let's go with the formal charge and dipole moment. Dipole moment depends on the charge because depending on if the molecule is polar or non-polar, in this case we can see it is non-polar, and the dipole moment will go from positive to negative. But we have to check that with the formal charge. How does formal charge work? Well, we know oxygen has 6 valence electrons, and we also know sulfur has 6 valence electrons. So now we will just subtract the electrons here, but the trick is that bonds, instead of counting as 2, they only count as 1. So if we try oxygen, this oxygen, it has 1, 2, 3, 4, 5, 6. So first one has a charge of 0. This one has 1, 2, 3, 4, 5, 6, 7. So it has a charge of -1 because we are subtracting 7 to 6. This will be the same 1, 2, 3, 4, 5, 6, 7. But now with sulfur we subtract 1, 2, 3, 4. Yeah, just 4. So it has a charge of 2. So now this is how the formal charge is done. Now let me do another example for, we can say this. So calcium has 2 and we subtract 4, so it has a charge of -2. And oxygen has 6 and we only subtract 4, so it has a charge of 2. So now we can see the dipole moment will go like this. So now salt, sodium only has 1 and we are subtracting 4, so it has a charge of -3. And chloride has 7 and we are only subtracting 4, so it has 3. So again the dipole moment will be like this. So I think, well, we can do it with this one as well. Hydrogen will have a charge of 0 here because it is 1. Carbon has 4 and we are subtracting 3, so it will have 1. This will be the same, and this will be 0. But now what happens? In theory, the dipole moment would go like this and like this, but because they are pulling to the same way, it will cancel out, so it has no dipole moment. And that is it for this video.